So the second topic is database management in GIS. What I was telling you is this is going to be a very, very logical, precautionary topic. You must always take these precautions that I'm going to speak about in this particular topic. Whenever you start with any GIS project, may it be small, may it be big, it is not always the situation wherein you are completing your entire GIS project at one go, you're publishing it, and after that you won't require that data anytime. Very difficult for you to come across any such situation. So in such cases, you have to always make sure that no matter when you visit that project, let's say you started it this month, you left it for another 2 months, and the third month you are visiting it back. So you should be knowing what you were doing those 2 months back, during that 1 month that you were working on that project and ultimately left it incomplete, and now you have come back because you want to complete it. So these are the precautionary things that we are going to talk about in database management in GIS. We are dividing it into three topics. One is nomenclature, because you start with some raw data in GIS. That raw data could be satellite data, it could be scanned satellite images, it could be scanned aerial photographs, or it could also be some scanned map that you have collected from other published resources, or that it could also be some data that is already available, vector data that is already available, and you are making use of it and things like that. So whenever you are using any raw data and then you are also deriving some data out of it, maybe you are analyzing that data and creating a new layer. So whenever you do this, you have to ensure that you name all these data sets in such a manner that next time that you visit this particular data, you will know what exactly you had done to arrive to that data, right? What method you had used in order to get this data and what this particular data represents. So we have to always standardize how we name any given file. For example, let's say you used a Landsat 8 image of January 22nd of 2025. So on 22nd of January 2025, there was a satellite image, Landsat 8 image, that was captured, and you have computed normalized difference vegetation index, NDVI. Okay, and everybody knows NDVI. Is there anybody who doesn't know what exactly is NDVI? N NDVI. Just give me a thumbs down. I'm not interested in thumbs up. I'm interested in thumbs down. If at all somebody has never heard of NDVI, then I will spend 1 minute and in telling you what exactly is NDVI. Okay, one. Anybody else? Anybody else who doesn't know what exactly is NDVI? Okay, great. All right. So let me tell you what exactly is NDVI. N for normalized difference vegetation index. Okay, so that is NDVI. What it does, this is an index, is a ratio. Okay, is a ratio between red reflectance and green reflectance. Okay, that helps us in identifying those areas where vegetation is present and those areas where vegetation is absent. Okay, so vegetated areas can be identified distinctly from the non-vegetated areas. So that is what NDVI does. NDVI doesn't really do only this thing, that is differentiating between vegetated areas and non-vegetated areas. Within the vegetated areas, it also helps us in identifying which vegetation is healthy, which vegetation is unhealthy. Okay, it also helps us in understanding where the vegetation is thick, that is dense, and where it is scanty or thinner. Okay, low density vegetation. It also helps us in identifying where this vegetation is in matured growth stage and where it is in old dying stage, or newly planted trees, newly planted, newly growing, very young vegetation. It helps us in differentiating between this. If you go a little beyond, NDVI will also help you in discriminating different types of vegetation. That is, this ratio which ranges from -1 to 1, below 0 means non-vegetated, above 0 means vegetated theoretically. So it will, this ratio will also help us in identifying specific kind of, discriminating between specific kind of vegetation. For example, dry land terrestrial vegetation that essentially you found on the mountains, that will have different chlorophyll content than mangroves, right? So NDVI values for these two will be different, so you will be able to distinctly see that the vegetation is of different species. If you are looking at aquatic vegetation, maybe on a lake that is completely covered by some vegetation, phreatic vegetation, right? It requires water, a lot of water, shallow water table or waterlogging kind of situation is exhibited in these regions. So there again, NDVI will help you in discriminating it. Now, so what I have done, coming back, just give me a thumbs up if you have understood what exactly is NDVI. The basic idea of NDVI, normalized difference vegetation index. Okay, there are different normalized difference ratios. Many are there. We will be, I think, talking about certain things later. I don't know whether in the theory or the practical session, but yes, we are discussing about it. So coming back, so I'm saying that on 22nd of January 2025, there was a Landsat 8 image taken by the satellite, and this image I have used for extracting NDVI. Okay, so I have to give a name to that NDVI image, isn't it? So what will I do? I will go for giving it a specific name. Will I simply call it final new NDVI? Makes no sense. This is a very vague name. Vague means what? Meaningless. If you come to it after 2 3 months, you might not know what exactly that is. Correct? No, final it says, new it says NDVI. We don't know what exactly it is. So while you name it in such a way that you are able to recognize what you had done and on what raw data you had done. So if I was to name this NDVI image, what will I name it? I will name it Landsat 8 or L8, L8 representing Landsat 8 underscore. See, I have always told you that underscore is always important. Okay, I'll tell you why exactly this underscore is important. In place of using a space to separate two words, always go for using an underscore, no matter whether it is your Excel file or whether it is your Word file, whatever kind of file ever that you are naming, even folder that you are naming, make sure that you use an underscore to name it. Always do that. I'll tell you why exactly a little later. Now, so what will I name it? L8. That means that particular NDVI was taken from L8 underscore 2025 01 01 22. That means what? I have also added what is the acquisition date. Landsat 8 has captured it on which date? So that date I am adding underscore NDVI. So now I am writing NDVI. That means what? I have used Landsat 8 data captured on this day, and this particular data is that of NDVI, and then I'm naming it, which means that I'm standardizing how I am naming my data set. I will show you some examples also later. Now, coming back, why am I emphasizing on you to add an underscore rather than using a space? Someday you are definitely not going to rely on your present day skills in GIS, isn't it? Someday you would want to learn a little more, and this data you would want to go for something like Python automation, or you want to go for R analysis on this data set, or things like that, where essentially you are using an algorithm or a coded program in order to assess this data and maybe extract some more information, statistical information out of it. You are trying to maybe generate new data set from this using a coded program, and that is where if you have a space, then the program will get discontinued. It will not recognize which file you want to go for analyzing, which one is that exactly input file, so that input file will become unrecognized. So always have this habit of adding an underscore. Now, even if you don't want to go to that extent wherein you want to go for any Python automation program or anything of that sort, There are certain plugins that you use in QGIS, or certain add-ons, certain tools that you use in any other proprietary software, like that of maybe ArcGIS and things like that, where the algorithms use your input file, mm, into an algorithm that is running that particular tool. Into that particular tool is designed into a language that uses your input file name, and then if it has a space, then it will not become recognized. Okay, it will not be recognized by the system, and the tool will not work on it. You will keep finding what exactly is the problem, you will keep searching what is the error that is coming, and you will not be able to figure it out. You will end up wasting a lot of time after it, and this is a very common problem that comes when you are a very new skilled person who is trying to um, navigate around these GIS systems and things like that. So just every time that you're saving any name, make sure that you give it a standardized name, so you are able to locate what exactly you had done while you were um, making this particular data and things like that. And then make sure that you are using an underscore in place of a space. Don't use that space bar. Okay, just give me a thumbs up if you have understood the nomenclature precaution. Okay, so always follow this. Okay, now the next that we are going to talk about is folder organization. Let's see, if we finish by 8, well and good. We have started also some 5 minutes later, so allow me to go maybe 4 or 5 minutes beyond 8 p.m. Right? So folder organization. Now, often you would want to make multiple folders within that GIS system. So some folder contains your raw data, satellite data. Some folder contains the scanned maps that you have made, or some folder contains the digitized layers that you have made. You have made some polygons, lines, points, so those are located. Some of your folders will contain something else other than this, maybe some tables that you have made, and some maps that you have made and things like that. So whenever such, all the time this particular situation is definitely coming to you, so proper folder structure for storing this data set is required. What is a suggested structure? Always make a separate folder for your raw data. Raw data is that data that you're using, maybe satellite data, maybe somebody else's data, maybe some scanned images. All this is raw data that you have not worked upon. It is not your data, you have collected it, so that you store in one folder. Once you use this raw data to extract some derived data from it, for example, you use Landsat data to extract NDVI, to compute NDVI, so that NDVI becomes your process data. Store it in a separate folder. Then once you draw some maps that you have already made, make sure that you save them in a separate folder. Output files, some files that you often go for changing into a different format, or maybe you would want to extract that information maybe in the form of an Excel or something like that, so you keep that separated. Any of your GPS data, survey data, if you have brought, that is your own data, that is your primary data, you have collected it from the field, make sure that you store it separately, so that you have a good structure of your project, and very sure what is where, rather than having just one folder and within that everything is lying. No, it is such a mess. So it will improve your workflow efficiency. You will know where exactly what is located, and it prevents data loss also. You will not be losing any data set anytime. Then coming to attribute data. Now that I look at it, I feel that maybe attribute data we will leave up to for tomorrow, and now I will show you some project folders. Okay, right. So right now, the practical module is going on, and this is the project one folder that I have made for that practical. So this is one project that we are doing for the practical module. When I open this particular data set, now until now only two classes have been held. So that is why you will see something like this. Okay, let me just delete this. Okay, so here what you see, there is a feature folder. Now within this, we had extracted some iron band. That is basically a BIF hill, and that is what we have is an iron ore band, it is that we had extracted. So that is our own data set. That is what we have extracted from satellite data, from Google Earth imagery, in fact. So that is what we have made, that is kept over here. Then another, we have also located some landslide along the Western Ghats. So those landslide points we have stored here, and some linear features like some river band courses and things like that, some linear bands we have noted. So all this is that information that we have extracted from the Google Earth imagery, and that is what we have stored there. Then this is downloaded dataset, India shapefile. These are basically administrative boundary shapefiles. That is India shapefile, then state boundaries, then district boundaries, taluka boundaries, the ones that we were interested in. We were interested in extracting Odisha. So for Odisha, we have made a shapefile. It's basically administrative boundaries that are kept in one folder. So you won't see anything else other than those administrative boundaries there. These are coastal districts of Karnataka, that is Udupi, Uttar Kannada, and Dakshin Kannada. So these are kept here in this India shapefile, this particular folder. And this is one of the satellite data that we had downloaded. Okay, this is one of the satellite data that we had downloaded, and we have kept it separate. That is, it is kept in its own folder. So here you see all this is satellite data, but within this folder, no, that is within this Landsat data, you will see a processed folder. So whenever we were making use of this raw data, that is satellite data, in order to extract something out of it, some derived information from it, some other layer that we make from these data set, from the raw data set, then we were storing it here. So we made a composite layer the other day, and that composite layer we have stored here. Now just look at this particular layer, that is a composite layer which we made, and we have named it in a particular manner. I just hope you are able to read it, that it is legible, no? What it reads, it's a composite underscore 1 to 4. That means band 1 to band 4 we have used in order to make this composite, because we could also use all the other bands also, but we have not. We have only used band 1 to band 4 in order to make this composite. And then again an underscore and the date of acquisition, that is on which date that particular satellite image was captured. It was captured on, like I told you, 22nd of January 2025. Okay, so this is the way that you will go for giving it some names. Now let me just show you something else if I have as well, some other project if there is one. Yeah. Okay. So look at this. So within this particular project, it is made for making some maps, and within that you will see some QGIS projects. One is for double map, that is there are two maps for that one project is made. This is Goa layout. Now besides that, you will see one folder for figures. So if you open it, you will see some figures in it. Okay, right. This must be a different copy. And then India shapefile. So this carries all the administrative boundaries. Then if you look at another map, here there are some lineament, this some kind of data that is stored. If you are from earth sciences or geology, essentially you will know what exactly it is, but otherwise don't be worried. It's just some kind of specific data. This is soil map. So here we have all the soil data set. Then this is recharge volume uh, change data set, that is groundwater, something to do with groundwater. Then recharge potential, then recharge volume. So different folders are made in order to store them. Now these maps, it stores all the figures, all the maps that are extracted. Okay, so that is what you will see. This is definitely an older one. And then LULC, recharge coefficient, some geomorphology map, study area administrative, and all these things. So you will see that separate maps are prepared for different purposes. So separate folders are made and they are named accordingly, such that next time when I visit it, I'll be able to know what exactly they are, isn't it? So this is called your GIS data management. Make sure that you always follow it, so that even if you visit your project after a very long time, you are in a position to figure out what exactly it is. Otherwise, in my download section, you will see many different things. There are some maps, these and that, but then it's just a mess. I might not be able to use all this very efficiently unless and until I have made a nice folder out of all this. Okay, so we will stop here, and let me see you tomorrow evening. Unless and until you have some question, I will stay back with you.